Hello, my name is Patrick Goudet, and welcome to my final presentation. I am looking forward to showing all my final results and further steps that can be taken in order to bring a little bit more out of this project. Here, once again, we have the motivation. It's like the main interest was to create a program which can refine itself, and make seemingly logical choices. That is the essence of artificial intelligence, neural networks, machine learning. The problem was finding a way to accurately predict the business trends in the stock market indexes. The solution that I found was using the NLTK libraries and scikit libraries, Python, and natural language processing or sentiment analysis in order to achieve this goal. Here we see my project plan. We're now in week 12 and turning in, obviously, my final presentation. And looking forward to getting some feedback on that. Here we have our applied method base. It's like we have the raw data cleaning. For each cell, we found the actual sentiment polarity. We split both into testing and training, and then we hit the Bernoulli, Gaussian, and logistic regression. And then later on, I added two more classifiers, which we will see in a second. Here we have the actual scatter plot of the raw data, and then the normalized data. We see that there's a nice differentiation once we actually process the data properly. And then we have a box plot of the actual entire mean with one or two outliers. Here we have the baseline, which ranged about 57%, which was obviously not all that exciting. Later on, so we then used, after the normalized data, we then we had then utilized the function and actually achieved about an 82%, which was very exciting for me. I thought that was great. I was like, okay, we're on the right track. I don't think it can get much better than this. Then utilizing the full data set, I then all of a sudden got stumped because I then only achieved 54%, which then I was like, okay, you know what, there must be something wrong with the data. I only found that the main problem was I was attempting to predict upon an index which was way too specific, which was the Facebook index, which is definitely more tech related. I had world news selected in order to do my actual predictions. Therefore, we needed a larger index, which then became the NASDAQ index. And we then all of a sudden saw a definite rise, which came up to about 68%. 79%, which made me feel much more confident with the actual data of choice. And then I knew that I just needed to manipulate the actual pre-processing techniques in order to actually achieve something better. I did that. What I did was I actually utilized only a certain set of data. So I noticed that after when I went past 2 to 3 years for the training, all of a sudden, I guess I was over predicting or overfitting at that point, but up to 3 years was absolutely fine. I think 3.5 years, so it was about 695 data points. I used that for the actual training and received a much better result. We can see that here. It's like, I mean, the logistic regression was still at 65, but the Gaussian naive Bayes came up to 73. The Bernoulli went up to 87. I then, at that point, felt confident to go ahead and implement the decision tree and the SVC cross-validation technique in order to go ahead and verify these findings. The decision tree here in this actual run came all the way up to 80%, and ranged with the cross-validation from about 70 up to 80%, which solidified my confidence in that. The SVM cross-validation, SVC cross-validation actually brought me up all the way up to 85%, which I thought was very exciting. Here, I'm going to go ahead and let the source code run just a little bit. It's a pretty long video, so I'm just going to go ahead and run through it really fast. This right here is my source code. It's shown in there where everything actually happens, the actual meat of the project. I will definitely give the link. It's like if you'd like to go ahead and see that. I'm going to go ahead and run straight through to the actual running of the project. So I've actually run it. We see it here. It's a little bit slow because it's very highly comprehensive. As we can see here, it's like, because this is the actual entire data that I actually used. It runs up to about 1,152 with by 159 type of matrix. So that was definitely a little bit comprehensive. If we move a little bit further forward, we can speed through this. We see here that it actually gives us the actual results, also at about an 80% accuracy. I then wanted to go ahead and show the actual website that I created for this system, or for this project. We see here it was an Angular project. I pulled it up. If we go a little bit further back there, we see the actual results. I will go ahead and give the link for that also in the actual final delivery. I found it to be very exciting, and I thought it was a nice little add-on for my final project. Once again, we see here it was very interesting to get the actual final up to about 84% of the stock market. Things that actually still need to be done from here on out, I would definitely say are definitely testing it on different data sets that are a little bit more specific. That would be definitely something that we could do with this. Once again, problems with data mismatch. Once again, just the further processing was a major issue. The solutions was I created a multi-class SVM, and that came out to be actually very, very exciting, very nice, all the way up to 80%. Once again, I believe that further steps would be needed just to go ahead and confirm the fact that using different data to predict more specifics, such as Facebook, would definitely work with this model. Here, once again, are my references that I utilized for this portion. In my final report, there are definitely far more. And I would like to thank you, and thank you for your time. And it's been a very, very great time here at UF. And I've been hired, and I've actually brought this thing to a close. And I thank you for your time, and thank you. Good luck.